All right, I was talking about system resources and how these are things that are shared between different devices, and how there's a limit to some of these resources, particularly the interrupts. They are particularly limited to 15 on today's PCs. There's lots of I/O port address ranges, and there's lots of memory address usually. But even memory is a limited resource. On a 32-bit system, you can have up to 4 gigabytes. So, for example, let's suppose you had a video card that had 1 gigabyte of memory that it could use. Now, that would mean that one of your 4 gigabytes is used up by the video card on a 32-bit system. Now, if you had a 64-bit computer with a 64-bit address range, it wouldn't be a problem because that has a lot more memory available to it. So that would solve that problem. But up until recently, that was kind of an issue. You could use up a big part of your memory for your video. And especially if you had more than one video card, then that could really be an issue. Direct memory access channels also very limited. There's only 4 of them, but fortunately not many devices use that, and they can be shared. Another thing that has to do with memory resources is called bus mastering. Bus mastering just means that data can be transferred directly between 2 devices without the CPU being involved, and that would be, for example, the video card and the hard drive controllers. They both use this type of technique. This is part of DMA, direct memory access. And what it means is that there's special signals that are being transferred, special control signals on a control bus on the motherboard that prevent collisions. Because what could happen is, let's suppose the CPU and was writing to the same location in memory that the video card was using at that moment and reading from. It could cause confusion, and it would cause data distortion. It would cause the video display to would flicker or look weird. And so bus mastering controls that and makes sure that nobody conflicts within the memory access, or 2 devices don't try to write to the same piece of memory at the same time, for example. Plug and play was developed to automate the assignment of resources. It used to be that you had to set switches or jumpers, little plugs that you plugged into expansion cards or a motherboard, to set some of these system resources. And, well, the problem with that was that sometimes people would set these little switches wrong, and then 2 devices would conflict with each other and things wouldn't work right. So maybe you'd install a modem. Modems seemed like they were particularly troublesome this way. You put a modem in, and it had a conflict with some other device, like the sound card, and so now you didn't get any sound anymore, or something like that. It caused a lot of confusion, and there were a lot of problems with PCs, particularly for people putting new devices in their PCs, to the point where they had to come up with something better, and they called this plug and play. And the idea was that you could plug a device in your computer, and the operating system would recognize what it was and configure things for you, and you wouldn't have to do it. And Windows 95 was the first operating system for the PC that had plug and play worked out, so it worked fairly well, although it wasn't perfect, but it was a lot better than what we had in the past. And really by now, plug and play works pretty good. Pretty much devices don't need to be configured anymore. You can still do some minor configuration inside the BIOS settings or CMOS settings, but pretty much most part it's all automatic today. Let me ask you a few questions. What was the purpose of an IRQ? Was it to identify the location of a device, to identify a direct channel to memory, to request the attention of the CPU, or to identify an assigned section of memory? Well, the answer to that is to request the attention of the CPU. The IRQ's job is to interrupt the CPU so that the CPU can be doing its job without having to check all the devices constantly. Now, it didn't always happen to be that computers used interrupts like that. I used to have a computer that didn't use interrupts. It had the capability in the hardware, but it didn't really use them. So it was constantly having to check the keyboard, for example. And if you typed on the keyboard, if your program that you wrote for it didn't check the keyboard, why, you could miss keys, and that happens sometimes. So that's one of the things that IBM PC put in that was a good idea because it made it more reliable. It didn't miss keys when you were typing. It didn't matter what the program was running, it would always catch the keys. The purpose of a memory address is to A. Identify the location of a device, B. Identify a direct channel to memory, C. Request the attention of the CPU, or D. Identify an assigned section of memory. Well, in this case, the memory address is used to identify an assigned section of memory. This will be a piece of memory that's devoted to a particular device. And so the memory address is range, it's a range of addresses, is devoted to a particular device that uses that piece of memory to store information or retrieve information. And then the CPU can also write stuff to that same memory, and it's a way of communicating. So for example, the CPU can communicate with a video card by writing stuff to the memory that the video card uses. The purpose of an I/O port address is to A. Identify the location of a device, B. Identify a direct memory channel to memory, C. Request the attention of the CPU, or D. Identify an assigned section of memory. Well, an I/O port is not the same as a memory address because its purpose is to identify a particular device. And each device has to have its own unique I/O port address. This is something we can't share. I/O port addresses are unique to every device in a computer. Fortunately, there's lots of I/O port addresses, not like IRQs. There's plenty of them, so this isn't a big thing. You just have to make sure each device has its own unique I/O ports. The purpose of a DMA channel is to A. Provide high-speed access to the CPU, B. Support direct data transfers between devices without CPU intervention, C. Request the attention of the CPU, or D. Allow devices to access memory without CPU intervention. Okay, well, the answer to that is for devices to access memory without CPU intervention. So like the video card can access memory without the CPU, and so can the hard drive controller. So they can both use DMA channels for that. Now I'll talk a little bit about troubleshooting the motherboard. A few hints for things that we can do to prevent trouble or identify trouble with a motherboard, and some of the causes. What are some of the causes of typical problems with a motherboard? Well, one thing that can be a big problem with motherboard is electrical damage. Things like lightning striking a wire outside of a building. So one of the really important things you need to have on a computer is something to protect it against voltage surges. And when we get into our chapter on the power supply, we'll talk a little bit about that. But the power supply is one of the jobs of the power supply is to convert AC into DC. But if a power supply gets hit by a high voltage surge from, say, lightning or some other high voltage thing like a big electric motor turning on and off, that can cause damage to all the components of the computer, and that would include the motherboard. So it's possible to have electronic damage as a result of surges. Fortunately, it's relatively cheap to buy protection today. You can get surge suppressors that you can buy, for your computer that come as a part of a power strip. You can tell they have a surge suppressor in, and they'll have a little circuit breaker switch on them that pops out, and those are great. I had that happen with my computer one day. I had a voltage surge at my house. Something went wrong with the transformer outside of my house that feeds my house, and it fried some of the things in my house, but my computer did have one of those on it, and it protected it. Now, most obvious thing to check when something goes wrong on your motherboard is the power. It has to have power, of course, and that means that the power supply has to be working. Now we're going to be talking about power supplies in a later chapter, so that's one of the things that we can check. In fact, that's one of the first things you should check, especially if everything's dead. We would check to see if the power supply is working and to see if the connections are properly connected to the motherboard. Also, the CPU is something you can remove. You can change your CPU. Mainly that's so if you want to upgrade your motherboard, you can put a faster CPU in. Well, sometimes those are not seated correctly, or they don't have the lever pushed all the way down. That'll, of course, cause problems, and because the connections to the CPU are not working. And other thing that can happen is expansion cards. The expansion cards could be not pushed all the way down in their slots. Same thing with memory modules. Sometimes they're not fully seated in their memory slots. What about I/O problems? Well, some of the devices that are connected to your motherboard use I/O input-output connections, output ports, and so forth. And one of the things that's a big valuable help to that is the power on self-test. So a lot of times if there's a problem, the power on self-test will find it for you, will tell you what the problem is. It may just put it up on the screen, or if it can't, let's say the video is the problem, it can't even put it on the screen, then it might beep. It'll beep, have a beep code. So you'd look up in your manual to find out what that beep code is. Another thing that you can do is the CMOS settings. The CMOS settings for the BIOS, they might be have a problem. They might be set wrong, or normally they're automatic with plug and play, but not always. Sometimes things do go wrong with that. So one of the things you can do is go into the CMOS setup program and look to see if there's anything obvious there. A lot of times it'll tell you things like, it'll tell you it can't find the hard drive, and it'll just say that. And that's something you would see then in the CMOS setup. Also, you can get diagnostic programs, special software that you can run on your PC. Usually these are programs you can boot up, like the operating system, and run them, and they will do system checks that are more advanced than, say, what the power on self-test from the BIOS will do. They'll do things like do memory checks. Sometimes there'll be a problem with memory, and the BIOS won't catch it because it's a transient problem, something that doesn't show up immediately. A memory diagnostic check can be run. Well, typically they'll run for hours or maybe a whole day. Sometimes they'll find a transient problem with memory if a memory is suspected. Another thing you can do is test some of the ports. If you suspect that you can't communicate with an external device like a printer or something like that, there are tests you can do on the ports. You can do what's called a loopback test on a parallel port or COM port. You can also do a test on your Ethernet or network port this way, and check them to see if they're functioning properly. Another thing that you can look for is just simple stuff like wiring. Inside of a PC there are various wires and cables running around. You need to make sure all those connections are seated properly on the motherboard. And occasionally what can happen is a wire can get pinched, which can cause pull a connector loose or even damage the wire. So you need to make sure that when you close the case on a computer that nothing gets pinched inside. So that can be bad. Just generally look at all the wiring in there. Often a lot of problems that happen with motherboards are just simply connectors and wires that are pulled out or not in their right place. Another thing you can do is if a motherboard has a problem, it might be due to a problem with a BIOS. A BIOS is a kind of program, and occasionally there's bugs in a BIOS, and problems can sometimes be solved by upgrading the BIOS. And that means that you'd run a special program called a Flash BIOS upgrade program, and it would allow you then to upgrade the BIOS with the new version if it's available. So you'd have to go to the website of the motherboard manufacturer to find out. Let me ask you a question. What are some things to check if a system doesn't power on? Well, the most obvious thing is your power source. It would be your power supply, and any loose connections, and just check to make sure things are properly seated, like all the connectors. Make sure the CPU's connected, the memory modules are fully seated. What procedures should you follow for upgrading a Flash BIOS? How do you do a Flash BIOS upgrade? Well, in order to do a Flash BIOS upgrade, what you would do is use a special program that you'd get from the manufacturer, and this would be a special process. And they would have instructions on how to do this. And actually, this is a somewhat dangerous thing to do, so you have to be careful that when you do it, you don't accidentally damage your BIOS, and you could actually make your motherboard so it wouldn't communicate with you anymore. So that's not good. Okay, well that ends my discussion for this topic.